In this final video, we're going to be talking about cryptography, which is a fancy way to really describe the area of mathematics that has to do with code breaking. So first, a definition. A cryptogram is a message written according to a secret code. As a fun fact, by the way, the word cryptogram actually comes from the Greek word kryptos, which means hidden. Hidden. Here, we're going to be studying a basic cryptography technique using numbers for letters. And because we're just starting off, we're going to use a very standard system for this. Namely, we're going to use the following system of encoding letters to numbers and vice versa. So we start by letting blanks be 0 and 0 represent blanks. And then starting with A being represented by 1, we go all the way up through all 26 letters of the English alphabet. So for example, what if we wanted to write the uncoded 1x3 row matrices for the following message? So because we're going to be doing 1x3, well, let's first write out all the numbers and then I'll write it down as the matrices. So meet me Monday. M is the 13th letter. E is the, I'm going to cheat throughout all of this. E is the 5th letter. So 13, 5, 5. T is the 20th letter. Then we have a 0. Then we have M, which is 13. E, which is 5. Then a 0. And then we have an M, which is 13. O is going to be 15. N is 14, D is 4, A is 1, Y is 25. And then to encode this, we then just break it up the following way into 1x3 row matrices. And then here, we don't have enough left, so we're going to put a 0 there to represent just a blank after that. Okay. So now you can try write the uncoded 1x3 row matrices for the following message, which is owls are nocturnal. On the count of 3, I'll reveal the solution. 1, 2, 3. And here is what you get when you do the encoding. Namely, you have 15, 23, 12, 19, 0, 1, 18, 5, 0, 14, 15, 3, 20, 21, 18, 14, 1, 12. Now that we know how to write them as numbers, to encode a message, we create an n by n invertible matrix, which we call an encoding matrix, okay? And so this encoding matrix will then mix everything up. So then we multiply the uncoded row matrices by A on the right to obtain the coded row matrices. So for example, if we had the uncoded matrix 13, 5, 5, and we had the encoding matrix 1, 1, negative 2, 2, negative 2, 2, negative 1, 1, 3, and 1, negative 1, negative 4. If we multiply those, we get our new coded matrix. And you can check this if you want, but it's 13, negative 26, and 21. So now let's go ahead and use the invertible matrix below to encode the message, meet me Monday. Now, if you'll recall from the first example, meet me Monday was given by 13, 5, 5, 13, 5, 5, 20, 0, 13, 5, 0, 13, 15, 14, 4, and 1, 25, 0. Okay. And so if we want to encode that, what we got to do is we got to do all of those matrix multiplications. Namely, we would have A, we would need to multiply this by A on the right. So we'd have 13, 5, 5 times A, which is 1, negative 2, 2, negative 1, 1, 3, 1, negative 1, negative 4. And going through, we end up with 13 minus 5, which is 8, plus 5. So those will cancel out, so you just get 13 again. Similarly, here you'll get negative 13 minus 5 minus 15. That'll end up giving us negative 26. And then you'll have, oh sorry, that was negative 26 plus 5 minus 5, sorry. And then here you would have 26 plus 15 minus 20, which will end up giving you 21. If you continue in a similar way, you would have 20 times 0 times 13, right? Times, I'll go ahead and just write A there. It's the same matrix though. You would also have 5 times 0 times 13 times A. Here you would have 15 times 14 times 4 times A. And then finally 1 times 25 times 0 times A. Sorry that I'm getting so sloppy. But speeding this up, if you were to actually go through and do these, you would end up with 33, negative 53, negative 12, 18, negative 23, negative 42, 5, negative 20, 56, and negative 24, 23, and 77. Now we have the following example for you to try out. So go ahead and use the invertible matrix given below to encode the message we saw before, which is owls are nocturnal. So you may want to go back and flip back to see what that message was encoded so that then you can speed up the calculation. On the count of 3, I'll reveal the solution. 1, 2, 3. So when you go through and you do all the encoding, you end up with the following numbers: 110, negative 39, negative 59, 25, negative 21, negative 3, 23, negative 18, negative 5, 47, negative 20, negative 24, 149, negative 56, negative 75, and 87, negative 38, negative 37. And of course, if you got the code, that would be the code you got, right? And so then the question is, well, let's say you're on the flip side. You're not trying to encode anymore. You're trying to decode. So you get those numbers and you're like, okay, what do I do now? How do I uncode it? Well, how do I decode it? Well, you need to know what the original matrix was. So let's say you know how the person encoded it. They encoded it by saying, okay, you have your message, we'll call it little m. You have your little message m and you multiplied by A. To get some coded message, we'll call it C. Well, to decode back, we would need to do some sort of a matrix. So this is encoding, right? M into C, your message M into C, okay? But then, to decode, what we can do is we can multiply both sides by the inverse to get M. So C times A inverse. But doing so, we then get the decoded message, which is M times I, so M, and then C, A inverse. And this would be the decoded. So this is the decoding now, which takes C back into M, right? But namely, we have sort of a two-step process. First, we have to find the inverse. Find A inverse, and 2, you have to decode to get the original message, So let's go ahead and do this process now. Let's use the inverse of A in the last example to decode the cryptogram. Now, that means first we need to actually find the inverse. The inverse, so the matrix we were given before was 1, -1, 1, -2, 1, -1, 2, 3, -4, and we want to find the inverse of that. 1, 0, 0, 0, 1, 0, 0, 0, 1. So to invert, the first thing I'm going to do is go ahead and add 1, add the top row, the row 1 to row 2 to eliminate, and I'm going to go ahead and subtract row 1 from row 3 to eliminate and get a 0 there. Namely, I would have this. Next, to go ahead, I want to make that a 1 and make that a 0 and a 0 there. So I'm going to go ahead and add this to the top. I'm going to go ahead and take -2 times this to the top row, and then +2 times the, well, first let's go ahead and do the following. Let's just go ahead and multiply the middle row by +1. That's an easier thing to do, which would give us this. And so now I'm going to go ahead and I'll eliminate in those two. So eliminating in those two will give me, I'll be adding 2 times row 2 to row 1, and I'll be subtracting row 2 from row 3. Namely, I would have, which will give this as the result. And then finally, as you see I already did, we go ahead and we take, we'll go ahead and fix this up while simultaneously subtracting 5 times it to that row, and 8 times it, subtracting 8 times it from the top row. And again, I said also fix it up by multiplying by a -1. That's what I wrote right here. And when you do so, you end up with this finally as your inverse. And now we can use that inverse to decode, to finally decode this. Namely, that's our second step. So we would need to take 13, this matrix, 13, -26, 21, and feed that through the inverse, which is -1, -10, -8, -1, -6, -5, and 0, -1, -1. Doing so, we would end up with doing all the row by column nonsense. We'd have -13 plus 26, so 13, and similarly continuing through, we get 5 and 5. Continuing in this way, you end up with the following result for the other 1, 2, 3, 4. 1 second. So 1, 2, 3, yeah. 4. Okay. 4 matrices, row matrices, and you end up with the following. The following matrix multiplications are now here. And so we would have that the final message would be M, E, E, T, blank, M, E, blank, M, O, N, D, A, Y, blank. So it would be meet me Monday, like we had in the first example. And now it's your turn to go through the lengthy process. Go ahead and use the inverse of the A in the last U-try example. And so look back at that, and you'll need to find the inverse of it, and then you can use it to decode the cryptogram. On the count of 3, I'll reveal the solution. 1, 2, 3. So here, going through and calculating the, I go through and I calculate the inverse. If in case you can't read this, that's R2 minus R1, R3 minus 6R1 to get that. Then I take R1 plus R2 and R3 minus 4R2. And then finally I do R1 plus R3 and R2 plus R3. Okay? Anyway, so that gives me the inverse. And then I go through and I do all the matrix multiplications to be able to get these numbers. And then reading off the numbers using my coding back into letters, I end up with our original message of owls are nocturnal. For more practice in this style of cryptography, be sure to see the textbook pages 595 through 597, and that is it. That is the last lecture for the course.